using trig ratios to find angle measures. So we already did the using trig ratios to find side lengths. So now it's angle measures. So this question says find the measure of the indicated angle. So the indicated angle might be indicated by a theta, that symbol in there, or it might be indicated just by a little arc drawn in like this one has. Could have one or both of those symbols. So we're trying to figure out how big is this angle. And we need to be given, first of all, it has to be a right triangle for this to work. So it has that little square in here saying this is 90 degrees. Has to have that. And then we have to be given two side lengths. And we're going to use the same ratios, sine, cosine, and tangent, as we were using before. We just use them a little bit differently. So for this, we need to decide which two side lengths do we know? Opposite, adjacent, or hypotenuse? We know the hypotenuse. Yep, that's here. And we know the adjacent here. Good. Remember, you look at the angle that you have. The one right next to it is the adjacent. The hypotenuse is the one that's opposite the right angle. So I usually look for the hypotenuse first, actually, so that I know which of those two is the adjacent. Once you decide which two side lengths you have, now you can choose a trig ratio, sine, cosine, or tangent, and you have to choose the one that has both of those side lengths in it, hypotenuse and adjacent.
Cosine.
Cosine, right. The cosine of an angle is equal to adjacent over hypotenuse. Then once we decide on that, we can just fill in what we know. So I'm going to leave this as cosine theta equals adjacent, which is 36, over hypotenuse, which is 47. To get the angle, theta is equal to cosine negative 1, the inverse cosine of 36 over 47. And you can find that on your calculator by pressing second cosine and then putting 36 over 47, or some of you it might be shift cosine, depending on the calculator that you're using. See if you can figure it out how to put that in, and let's see what the answer is. I got 40 degrees. Anybody else get 40 degrees? Yeah? The thing you need to remember, really, when if you're finding an angle, in whatever situation, if you're finding an angle measure and you're using trig ratios, you have to use that second cosine or second tangent or second sine. It's the inverse cosine or inverse of the trig ratio when you're finding an angle. So if we look at this next problem, find the measure of the indicated angle. Start out the same way. Which sides do you know? Opposite, adjacent, or hypotenuse? We know the opposite is here, and the adjacent is here. Since the angle's here, this is right across from it, this is beside it, opposite, adjacent. So opposite and adjacent, which trig ratio is that? Tangent, right. So we'll go tan of an angle is opposite over adjacent. Tangent of this angle is opposite, which is 87, over adjacent, which is 26. And then like we did before, to get the angle, we have to do tan negative 1, the inverse tangent of 87 divided by 26. When you put that into your calculator, you get that theta equals 73 degrees. Often we'll round an angle to the nearest whole number instead of saying like 73.4. Unless it tells you otherwise, I would usually round an angle to a whole number. So 73 degrees. This one's a little different because it's a word problem, but it still works the same way. It says, a 5-meter long ladder leans against a wall with the top of the ladder 4 meters above the ground. So I'm going to draw a picture of that. Here's the wall and the ground, and you have this ladder leaning against it. Oh, that's not a very straight line. Let me try that again. A ladder leaning against it. It says the ladder is 5 meters long, and that the top of the ladder is 4 meters above the ground. So that's this distance from here to here. This is a right angle, and it says what is the angle that the ladder makes with the ground? So that means we're trying to find this angle down at the bottom. If this is the angle down here that we have, then we have this side, which is opposite, and this one, the hypotenuse. Opposite over hypotenuse is sine. So the sine of the angle is opposite over hypotenuse. Just be careful when you fill it in. Make sure you're filling opposite in as what the opposite side is, and the hypotenuse, the number's in the right spot, 4 over 5, not 5 over 4. And then to find the angle, inverse sine of 4 over 5. And that works out to 53 degrees.